Good morning, everyone. This is Manisha, an assistant professor in Computer Science Engineering Department of IIMT College of Engineering, Greater Noida, Uttar Pradesh. In today's session, we will discuss about normalization in database. Before leading towards normalization, I would like to give some brief introduction about database and keys. What is database? A database is a collection of organized data which should be subject-oriented. How do we find out our data is organized or not? If data is stored in form of tree, in form of graph, in form of table or any other acceptable format, we can say that our data is stored in an organized format. And what is subject oriented? For example, if we will create a database for university, so here we cannot store data of Indian Railways or Indian passport. If we will try to do that, definitely it will increase complexity of database, and for end user, it will be difficult to understand which database is related to for a particular subject area. That is a basic concept of database. Now move towards keys. What is keys? A keys is an attribute or set of attribute which is used to uniquely identify the table for their unique identification. Like keys further divided into such several categories. Candidate key. A candidate key is a minimal super key. In a student table, student roll number, contact number, address, email ID, candidates, candidate key. Primary key, most appropriate candidate key, which is basically used for unique identification and which cannot be null ever. This is known as our primary key. Then super key. When you combine two and more than two candidate key to make a one more strongest key for unique identification, then that is known as our super key. This is a basic building block which is important to understand concept of normalization. Now move toward our topic, normalization. Normalization is used to reduce data redundancy and also it's used to reduce data duplication in database. Normalization also helps to remove insertion anomaly, deletion anomaly, and updation anomaly. What is anomaly? Just to understand this, now look at this table. Here I have a table, student table, where I put the record of 4 students. Their name is mentioned here, branch, department, contact number, and mentor name is mentioned here. As you can see that still we have the only record of 4 students. But what will happen if we will try to insert more and more data, maybe more than 100 records? Now it is already visible. Branch, department, contact number, and mentor name is repeating again and again. So maybe 100 times the data will repeat itself again and again, and it will increase the size of occupation size in database. To overcome from this problem, what we can do that here we can divide the data base table into two different subtables. The first table, in the first table, we will put the record of a student, and in the second table, we will put the record of the branch. Suppose in future, if their mentor get changed, what we have to do now? Just one time update the information in branch table. Automatically, this information will be taken by table 1 for their future reference. This is the concept of normalization. Now, normalization is further divided into some more categories. That is first normal form, second normal form, third normal form, policy called normal form, fourth normal form, and fifth normal form. One by one, we will try to understand all these forms with their proper explanation. To start with the first normal form. First normal form, it is called when it fulfills some criteria. In a first normal form, data should be represented in an atomic manner. It means in a particular row, no multiple entry over more than one data is allowed. Then when we choose a column, every column has some unique name, and here we have to assign a proper primary key in each and every individual table for the unique identification of database. Now look at this table. Here we have our table, that is product table, and some ID is listed below. Color is mentioned here and the price is mentioned here. In table product, our product ID is our primary key because no row is blank here. It means it's not accept any null value, and also it has a unique value for its representation. Then If we will see the color for row 1, in the same row we have two entries, that is black and red. And in row 4, in the same row we have two entries, that is green and blue. This is against the concept of normalization. According to normalization, only atomic entries allowed in a particular row. So what we can do here, to change this database into first normal form, we can decompose this database. First of all, decompose this database into two different parts. In the first table, make an entry of product ID and price, and in the second table, make an entry of product ID and a color. In the first table, our product ID will be our primary key. In the second table, product ID and color. Both will be combined and we get a new composite primary key with a combination of product ID and color. As you can see that now we have removed multiple entry in a same row. Every row has an atomic entry. So now we can see that our database represents itself in a first normal form. After that, we will lead towards the second normal form. Criteria of second normal form is listed here. First one, data should be always present in the first normal form and no partial dependency is allowed here. What is partial dependency? Just to understand this, now look at this table. Here we have a one table, that is purchase detailing table. We listed below some columns here, that is customer ID, store ID and location. If you will look carefully at the data, then you can see that no single column itself represents itself as a primary key because in each and every column data repeated itself again and again. Just like in customer ID, value of 1 is repeated 2 times. In store ID, value of 1 and 3 is also repeated 2 times. Then location is always repeated the data again and again. First of all, our target is to create our primary key. How we will do that? Combine customer ID and store ID all together and make a new primary key. It will be our primary key for the purchase detail. So we can say that customer ID and store ID as a composite primary key will be our prime attribute and location will be our non-prime attribute. Prime attribute always give a reference of non-prime attribute. But if we will look carefully, we can see that the store ID, which is a part of a prime attribute, also give a in a single manner also give a reference of a location which is not allowed and it is show the chances of the partial dependency because store ID is a part of customer ID with a composite primary key. So alone it cannot give a reference with itself. How will we come overcome this problem? Again, we have to decompose this table into two different parts. In the first table, we will put the data of the customer ID and store ID. And in the second table, we will put the data of the store ID and location. In the first table, our customer ID and store ID will be our composite primary key. And in the second table, store ID will be our primary key and location is right now fully functional dependent on the store ID. So here we remove partial dependency. Now we can see that our database represents itself in a second normal form. After second normal form, we will lead towards the third normal form. What is the criteria of the third normal form? If a database represents itself in a third normal form, first of all, it has to fulfill all the criteria related to the second normal form. In third normal form, the most important criteria is that here no transitive functional dependency is allowed. What is that? To understand this, now look at this table. Here we have designed one table that is book details table and have four columns. First column is book ID, second column is general ID, third column is general type, and fourth one is price. If we will see the table carefully, now we can see that our book ID will be our primary key because no null value is present here and all the unique values is listed in a book ID column. So with the help of book ID, if we want to directly access the general type, we cannot do that because for book ID 1, we have the general type fiction and also for the book ID 3, we have the general type fiction. For book ID 2, we have the general type sports and for book ID 5, we also have a general type sport which is not allowed. Because for a same general type, we always need a same book ID, not a different one. So how we will access the general type? To access a general type, first of all, we have to start with the book ID. It will take us towards the journal ID, and from the journal ID we will lead towards the journal type. We do not have any option from book ID to journal type direct path. It will show the condition of the transitive functional dependency. To overcome from this problem, what we can do there? Again, decompose the table into two different parts. In first part, make an entry of the book, and then in the second part, make an entry of the journal. In first part, book ID will be our primary key, and in the second part, journal ID will be our primary key. Now we have removed the condition of transitive functional dependency. We can see that still our data represent, or we can say that right now our data is capable to represent itself in a third normal form. After third normal form, we will lead towards the Boise-Pod normal form. It is also known as an extension of third normal form, or sometimes we will call it is an with the name of 3.5 normal form. Here we have to take care of the one parameter, that is maintain a super key. How we will do that? For that, now look at this table. We have designed a one table, that is our student table, and put some records of a student, make a second column of their course, and third column of the teacher. First of all, design a primary key. To design a primary key, combine student and course column with each other and make our composite primary key. Now, as a primary key, student and course give a reference of teacher. But if you will look at carefully, you can see that teacher also give a reference of a course which is a part of a super key or our primary key, which is not acceptable. So how we will remove this problem? To remove this, again we will decompose the table. When we decompose the table, then we will get a new two table. In a first table, we will put a record of student and course. And in a second table, we will put a record of a course and a teacher. In the first table, student and course will be our combined primary key. And in the second table, course and teacher will be our combined primary key for a unique identification. After policy for normal form, we will lead towards the fourth normal form. Our fourth normal form has to fulfill some criteria. First of all, it has to represent itself in a first, second, third, and policy for normal form. After that, here no trivial multi-value dependency is allowed. What is that? To understand this, now look at this table. Here we again design a one student table. If you will look at carefully this table, you will find out a fun pattern. Like one student has opted a more than one major or more than one hobby. Like Aman has a one major, that is management, but he opted a two hobby, that is football and cricket. Also Raj, as a student, he opted a two major, that is management and medical, but have a only one hobby, that is football. So first of all, design our primary key. For that, combine all three columns with each other, that is student, major, and hobby. Now, where the multi-value dependency it exists in a column of major and hobby. So how we will remove this multi-value dependency? To remove this, again decompose the table. In a first table, put a record of student and major, and in a second table, put a record of student and hobby. In a first table, student and major will be our combined primary key, and in a second table, student and hobby will be our combined primary key. Here, we remove the concept of multi-value dependency. Now we can say that our data represents itself in a fourth normal form. It is capable to remove concept of multi-value dependency and also partial dependency and multi-value function dependency. After that, we will lead towards the fifth normal form. If a data want to represent itself in a fifth normal form, first of all, it has to be represent itself in a first normal form, second normal form, third normal form, fourth normal form, BCNF normal form, and has to fulfill the criteria of rejoin. What is that? For understand this, now look at this table. Here we have designed a one table, that is seller table. We have put some column. First column is assigned for seller. Second one is for company, and third one is for product. First of all, design our primary key. Just design our primary key, combine seller, company, product with all together. And if you can see that the seller Aditya has opted a company Unilever three times, but he has opted a more than, or we can say that three products, that is Pond, X, and Lakme. This is so our multi-value dependency, and also seller and company product. Seller and company give a reference of the product, but as a product also give a reference of a company, which is also for the condition of the the functional dependency. How we will remove that? First of all, represent or decompose this data into third normal form and fourth normal form, just like we did it here. Decompose this data into two different tables. In a first table, put a record of seller and product, and in a second table, put a record of seller and company. Now we can see that our data is capable to represent itself in a unique manner. After then, now look at the same column which is represented in both the table. That is seller commonly table number 2 and table number 3. So we will remove that and combine product and company together. When we will combine product and company together, now we can find out after merging company and product, and when we get a new table, here no new entry will be allowed. So new entry is present here or not. Just to check that, now take one example. If you will operate a company PepsiCo and choose a product Pepsi. So in previous slide, we can find out for both the company and the product, our seller was Aditya, and also he was present itself in our initial table. So now we can see that no new entries listed here. So our data is right now present in a fit normal form. I hope now you are able to understand the concept of normalization. With that, I would like to wind up my session for today. I hope you have enjoyed the session. Thank you so much. Have a good day.